Welcome to lesson number 30. Learn C programming on the Raspberry Pi. Well, last lesson we started talking about pointers, and today we're going to continue our discussion. So let's first bring up Jeannie to see what we did last time. Okay. So this is our previous day's example, and just to quickly go over it once again, we declared three variables here. We'll start with line 6. We declared an integer x and we assigned it a value of 42. On line 5 we declared p to be a pointer to an integer, but we did not initialize it to anything. And then on line 4, we declared p1 as a pointer to an integer. And again, we didn't initialize it to anything. Well, on line 7, we initialized p to the address of x. So p now is pointing to x. And then we printed out the value of x. We printed out the value of p. And then we printed out the value at p by using the asterisk as a dereference operator. So remember, the asterisk is also used as multiplication, as the multiplication operator, but in this case we're using it as a dereference operator. And then on line 13 we but we actually assigned a value to p1, which was the address of p. And then we printed out the value of p1. We printed out the value at p1, and then we printed out the value of the pointer to the pointer at p1. Okay, so this is all very nice, but probably still confusing. So let's go on with another example here. So I'll create a new file. And here I'll declare, instead of dealing with integers, let's deal with characters. Say character x is equal to, let's just say it's the capital letter J. And then we'll also declare a pointer to a character, and we'll call it star p. So that's a pointer to a character, and we haven't, if we want, we might as well initialize it on the same line, is equal to the address of x. So p is now a pointer or pointing to x. And so let's just, again, we'll print this out quickly. We'll say x is %c/n quote comma x, and then we'll printf like this, star p is %c/n quote comma star p. So just a small program to start us off. It will get a little bit more complex later on. So let me save this guy here. Save as. And I guess I'm going to have to put him into lesson 30, so I better create a new folder here in my lessons directory. Create a folder, and I'll call it lesson 30, and I'll call this I don't know, POIN point. Let's just call it point.c. Okay. So let's take a look. Let's do a diagram of this as well. I'll bring up my little paint program here, like this, just so we can see what we're doing. So first of all, I have here I have the variable x, and inside x I put the capital letter J. And I also have the variable p here. Here's the variable p. Okay, so I'll just put it outside here. And now I've also initialized p to the address of x. So p really is pointing to this guy here because it has the address of x inside here. Okay. So that's basically what we have. And if I was to bring up a terminal here and let's see, change directory to lesson 30, and I'll go C99 minus O point. So I'll just compile it like that and then execute point. Okay, so we can see that x is j and the value that p is pointing to is also a j. Well, let's put some other numbers on here. For example, I also want to know what where x is stored. Address of x is, and I'll just say %p /n quote comma address of x. So we'll save this guy, and I will just compile it again and run it again. And now you see the address of x is this guy here. So this is the hexadecimal address of x. So let me write that down here. Let's say BEA1. Let's see, BEA1 3233 3233. Okay, so that's the address of x. So that's where this j is actually stored, at this location. Okay, well, let's go and do a little bit more here. Let me get the address of p. I'll do the same thing here. Quote, address of p is /n quote comma the address of p. Okay, because p is a pointer, so that pointer has to occupy some place in memory. So let's see where exactly P is. I'll compile again. And now we see the address of P. So P is, I'll just put it here, BEF54. In this case, it's different now. You notice when I added in this new line of code, all of a sudden the address of X changed as well. Okay, so I'm not going to bother changing the address of X here. I'll just put in that this guy here is BEF54 F54 230. Okay, so it's just important to note, you see, it used to be X was at this location here, but now I've added in some more code, so now where X is in a different spot. But that's okay. What's important to note is that both X and P have addresses. So P is located here in RAM. Okay, so this is the address of P, and this is the address of X. So each of these locations have an address. Okay. So now what we'll do is we'll also print out the contents of P. Well, we'll print out P itself. So how are we going to do that? Let's see, P. That's what it's pointing to. So let's just print it right here. Just like I said here, I said X is and star P is. Now I'm just going to say P is percent P slash N, quote, comma P. And let's see what we get with this. We'll save it again. We'll go through the compilation again, print it, and now you can see, you notice the address of X is this number here, but you notice that P is the same. P is the same. So if I was to somehow, I don't know if I can magically erase this. Well, I guess I could just take that and just strike that out, make it simple. If I start off now this way and I just say, well, this is X and it has a J in it. Well, this guy here is P, and inside P is this beef 3237. So I can just put that in here, B E E F 3237. And you see, if I was to say X, the address of X is beef 3237, and the contents of P, like what P is 3237, is pointing to that J. Well, let's go a little bit further. would like to show you that we can change the value of x. I could change x by saying, for example, x is equal to the capital letter K. I could change it like that. Okay. Change x, right? Or, because I have a pointer to it, I could change it this way. P is equal to, quote, let's say put a capital L in there. Oops, single quotes. So, again, change x. What's interesting here is that you notice I have this, the value of P, or this dereference operator. You notice it's on the left side of the equal sign, which means I'm basically assigning a value to it instead of up here like I was, well, here I'm assigning a value as well to it. The value is the x, the address of x. And here I'm just putting an L into it. So what do I get when I print out x? I'll just say now x is %c/n quote x. Okay, so let's do this again. Save it. Compile it like this. Oops. Should have put a comma here. Sorry. Comma. Save it again. And run it. And you see X is L. So for a very small time, right here, for a time, X was equal to K. So because I made here on line 11, I changed the value of X to a K, but then immediately afterwards I changed it to an L. Okay, so this is important to know that you can do this with pointers. You can have it on the left-hand side of an equal sign or an assignment operator. Okay, so let me clear this out here. Just discard all this, I don't need it. And let's go on to another example here. I'll just save this guy here. Let's go on to another example, but this time I'm going to show you well, let's talk about arrays now. So let's start a new example here. And this time I'll just make an array of integers. Int, say x, and I'll initialize it to, let's say the number, let's say prime numbers like 1, 3, 5, 7. I'll initialize it to those 4 numbers, 1, 3, 5, 7. So, in fact, I think what I'll do is I'll call this guy, well, it is an array. I don't have to call it by the name array. I'll just call it X. That's good enough. Okay, so I can do like a for loop and I can print out those guys. Okay, so I'll say for int I equals 0, I is less than 4, I plus plus. Okay, and I'll just print them out. And I'll say x bracket %d close bracket. Try to make it nice, to print out nice. D equals %d slash n quote comma, and the first %d is going to be I, and the second %d will be x bracket I, or the value of it. Okay, so let's just say return 0 and close this guy off, and I'll save this guy as, let's say save it as, and we'll call it in lesson 30, I guess I'll just call it 0.1. Well, let's call it array, array.c. Okay. Okay, so this is straightforward. We covered this in an earlier lesson, so you should know what this is going to do. So we've already saved it. Let's go and compile it. And I'll call this a array. So array. Oops. What, did I make a mistake here? That's not a period here. That should be a comma. On line 6, you notice I have a period in here. It's pointing right to my mistake. So I better change that to a comma. And I'll save it again. And we'll try recompiling. And this time we're successful, and I'll run it. Array, and I get x at 0 is 1, x at 1 is 3, x at 2 is 5, and x at 3 is 7. Again, remember, in my for loop, I'm declaring the integer I here as my counter variable, control variable. So I really does not exist outside of the for loop. It exists only inside the for loop. Also remember that in my for loop I only have one statement, so it's not necessary for me to have braces. But I'll put the braces in. Oops. I'll put the braces in just in case. Well, not just in case, but just to make it more obvious what I'm doing. Okay, and just to make sure it still compiles correctly and it runs, get the same thing. Okay, so this looks pretty straightforward, but the question is, what does this have to do with pointers? Well, they have a lot to do, because in some ways arrays and pointers are kind of duals of each other. They work very similar, in other words. So let's make a pointer here, a pointer to an integer here. Okay, and what I'll do later on, after I do the print, okay, what I'll do is I'll give that pointer a value. P is equal to, and I want to give it the value of the second element in the array. Well, the second element in the array is 3, but I want to give it the address of the 3. So this pointer P, I want it to point to the address of the 3. So I'll say the address, the address of x bracket 1. Does that make sense what I just did? Because you see here here is x0, here is x1. So if I say P is equal to the address of x at 1, well, the address of x at 1 contains a 3. So now if I say, okay, let's say printf star P is %d/n quote comma star P. So I'm going to print out the value at that address P. Let's try it. Save that guy. Compile again. Run it. And you notice the for loop prints out these guys here, 1, 3, 5, 7. But look at this, star P is 3. Star P is 3. Okay, well, let's go one step further. If star P is 3, let me increment P. So I'll go P plus plus. So what am I doing here? I'm adding, it would look like I'm adding 1 to the value of P. But P is an address of an integer. And an integer is 4 bytes long. So what I'm really doing here is I'm adding 4 to the address P. I know that sounds a little bizarre, but this is basically, it has to do with pointer arithmetic. Pointer arithmetic. Okay, well, let's see what happens. I will now print out the value of P again, the second time. So I save it. I go here, compile it, and now I run it. And you notice that now P is pointing to the 5. See, initially I had P set up as the address of x at 1. But now I moved P over to the next guy, which is x at 2. And that's why it became 5. Well, let's see if we can make a little diagram of this. Okay, so here we have, here I'm going to show you x. This is x. Well, x is 4 integers, so I'll just divide it up like this. Like this. So in the first one I have a 1, then I have a 3, then I have a 5, then I have a 7. Now, just for fun, let's say that this address here of this 1, let's say he was address 100. We'll keep it simple. So this is going to be the address. D R E S S. So that's the address 100. So what would be the address of the 3? Remember that every integer is 4 bytes. So the address of the 3, if this is 100, 101, 102, 100, 101, 102, 103, then this one would be starting at 104. So the 3 would be stored at location 104. And it would take up 104, 5, 6, and 7. So the 5 would be in location 108. And the 7 would be in 112. Because see, each integer takes up 4 bytes. Each integer takes up 4 bytes. And so here, this line 11 does not increment P by 1, it increments P by 4. And we can show that. I can print that out. For example, let me print out P just before and after. Printf P is percent %P slash N quote comma P. So I'll just print out the P as the pointer, and then I'll print it out after I did the increment, like this. P is, let me change this one to P is now, so you can see what the value of P is before and after I do the increment. So let's save this guy, and then I'll go and recompile, and I'll run it, and you can see that before the address was 4, but afterwards it was 8. So it moved over by 4 positions, or 4 bytes. So this whole concept of pointer arithmetic is very important in C, also in C++. But the point is that whenever you're adding to a pointer, you are really adding enough bytes, or as many bytes as needed to hold that data. So if P was a pointer to a character, and I added 1 to that pointer, then it would just add 1. But since P here is a pointer to an int, when I add 1 to it, I'm really adding 4 bytes, or 4 to it. Okay? Okay, so that's kind of that for now. Let me just see here. Boom, boom, boom. Okay, so one more thing. This is pointer arithmetic. Let me see if I can bring up our, do I have my notes here from before? Let's see, file, open, I have a recent, I don't have notes. Oh yes I do, here we go, notes. So let me go to the bottom of these notes here. C99, C language operators. Electronics. Boom. C language terms. Well, we can also say now with the asterisk, pointer 2, it has other meanings as well. Multiplication, we can say, well, it's basically a dereference operator. What else can we say here? Language statements, functions, library functions. Let's go here. Terms, address pointer. I guess we should add in here pointer arithmetic. You can actually do a Google search on that, and you can read about pointer arithmetic to see just exactly how it works. Okay, so I'll save this guy, and let me go back to my array here, and let me finish off today's lesson with this idea here. Printf quote, let's say x is %p, comma, and then I'll say address of x at 0 is %p okay, we'll see what we get here. So the first one is going to be just x, and the second %p will be the address of x bracket 0. I think this should do it. So let's save this guy, run it, then we'll see if we can explain it. We'll go through compile again and run it. And now you can see that I printed here x. See, up here x is an array. So the name x by itself, if you look at x by itself, it's really an address here. This is x by itself, and it happens to be the same address as x0. See, they're both identical. What's important to remember, though, is that here x is not a pointer. X is really the address of an array. So it's a subtle difference there, but it's important to keep in mind that x is not a pointer. X is an address of an array. P, on the other hand, is a pointer. Okay. So here I'm printing out x, and I'm printing out the address of x0. And you can see that they're both the same. They're both the same right here. Okay. I think that's probably good enough for now, unless I have anything else to add. No, we're still, to be honest with you, we're not finished with pointers yet. I think I'm going to need one more lesson, probably lesson number 31. So for homework, see if you can run these programs, do some research on pointer arithmetic, review the previous notes we had in earlier lessons on arrays. And oh yes, there is one more thing that I should take care of before we finish, and that is, I notice not very many people are downloading the source code that I have on GitHub. So let me just see if I can just do that here. Here's the address of my GitHub repository here for C on Pi lessons. If you want to download that, you just need to have access to Git. And so if you do, I think I have Git here on the Pi. I think I can do Git help if I did just git help command like that, and then you can use the clone option to clone a repository. Okay, so if we did that, do we just do it like this? Clone .com / C underscore on underscore pi score lessons. Oops, should be capital pi, I think. Capital pi. Okay, so I just entered this command. If you don't have git installed, you can just install it using the apt-get install command. And all it does is it just downloads everything. Here, if you look, I now have C on Pi lessons. I have a directory here. I can change directory to C on Pi lessons, and you can now see the lessons directory, and you have all of the code here plus the notes for this course. Okay, so I think that's probably enough for today. Let me bring back my recorder and I'll stop it, and I will see you later for lesson 31.